welcome and thank you for coming to my session. I'm calling this session a level 200 session, and so basically what that means, it's not introductory, but at the same time it's not the most complex that you'll ever come across. I originally thought this was going to be a level 300 session, but I do cover everything that you need to understand. The main difference between what I'm talking about here today and the way I would teach this in one of my two-day classes is I would normally take 2 days to teach what I'm going to cover in 40 minutes. And believe me, that can make a difference because there's a lot to absorb and you don't always understand the implications of things. They seem simple on the surface, and it's usually good to get a little bit of practice in between. Let me start off by introducing myself, if I can get my clicker working. So my name's Matt Allington. I spent literally half of my life selling sugar water to people in Australia. And, but one of the great things about working with a big company like Coca-Cola was I got to do a lot of different things. You can't spend, well, I guess you can spend 25 years doing the same thing, but I certainly didn't, and had lots of opportunities of working in the business, solving business problems, and also working in IT, solving IT problems on behalf of the business. And you know, one of the great things that I took away from that 25 years was my ability to sort of sit either side of that fence and really understand the nuances of both groups of people, and that's really, I guess, took me into my current life where I'm a professional BI consultant. Been doing that for the last 3 years. Been super thrilled at the timing of my decision to leave Coke and become a BI consultant, because you seriously couldn't be alive at a better time than now, I believe. So I do self-service BI consulting mainly. I tend not to get into the enterprise stuff. So I like to help real people with their desktop problems rather than getting involved in the IT problems and the IT enterprise solutions. I'm not saying that's not a thing. It's definitely a thing. It's just not my thing. There are other people who are better placed to do that. And so I do a bit of online training. I do a lot of live training courses, and I do a lot of blogging, and love sharing what I learn with other people. And so you can have a look at my blog there if you're interested. I wrote a book last year, Learn to Write DAX, which is particularly on this topic, and I'm also a Microsoft MVP. I just want to get a sense of who's in the audience so that I know roughly where you guys are coming from. So who would describe themselves as a SQL professional or someone who works with SQL in a technical sense ongoing? Okay, so it's about the same as before, about half the audience by the look of it. And so for that group, anyone doing SSAS multi-dimensional work, so MDX people, that's a reasonable number actually. It's not normal to see that many MDX people. And what about anyone moved over to Tabular already? So there's probably just a fraction more than that. Okay, so that's the IT crowd. And then who would class themselves as an Excel pro or an Excel user? So I would expect, generally speaking, the other half, probably more than half. So excellent. I'm one of you guys, so I get you. And for really everyone, so like who's had no DAX skill at all? Like who's basically, it's brand new? Not too many. Excellent. And who would call them sort of middle? You know, I started and. Okay, and then who would say they're on the other side of middle, so I'm now getting, okay, fantastic, that's great. Okay, so we've got a real mix. In fact, this is one of the scourges of teaching Power Pivot is variety of skill set. And so I can teach a class of 20 people if they're all experts or if they're all beginners, but it's pretty difficult to teach a class of 20 when you've got this sort of wide range. But I'm going to do my best to make everything make sense to you here today. Oh, sorry, one more question. Context transition. Who's already got, I promise I won't call you out if you stick up your hand, but who says they sort of understand context transition, the principles? Okay, great. Well, that's pretty much what I would expect too. Okay, so the agenda, I'm going to cover everything. So as I said, it's not that I'm going to say, well, you should know that. I'm not going to talk about it. I'm certainly going to talk about it, but I'm not going to spend a lot of time talking about it. So, so keeping in mind that I would normally do this over 2 days for a new group of users. But given that most of you are sort of intermediate, it's probably about the right pace anyway. So I'm going to do a few slides introducing evaluation context and putting my spin on what that means. And then we'll do a few examples on row context, filter context. I'm going to talk about the calculate function and context transition. And then I'm going to wrap up with bidirectional cross-filtering. I did have a backup slide on, someone asked me in the foyer whether I was going to explain how Rob Colley's greatest formula in the world works. As it turns out, I actually did have that slide or an equivalent of that slide in my deck, which I pulled out at the last minute, but we'll see how we go for time. Might get to that. And so we've got 40 minutes of me talking and 10 minutes of questions, but frankly, I'd prefer you to yell out as we go. So, because it's better to talk about it if it doesn't make sense or you have a question, just shout out. We'll do our best to capture that and give you an answer throughout. And if we use up some of the 10-minute question time doing that, then that's fine by me. Okay, let me start off by talking about relationship types. And so this is a simplified star schema. It would be totally familiar to all of the SQL folk. But if you're an Excel pro, then this is probably a new concept for you. And so it's called a star schema for the layout reasons that you can see on the screen. There's this table in the middle, and you've got these sort of satellite tables floating out on the points of the star. And this is actually a simplified version of the AdventureWorks database. For those of you that are familiar with that, AdventureWorks is a retail bicycle business, and it sells bikes and hats and clothing and a whole lot of stuff. And I use that for my training, and the guys at Power Pivot Pro do the same. So we like to keep things consistent so that you get a consistent message as you read and learn. And so the reason this is a simplified data model is that over here, this products table in the real version of AdventureWorks has got a subcategory table that sort of floats off down the bottom here. And then there's a products category table that floats off underneath that as well. And so once you start having lookup tables connecting to other lookup tables, it's technically a snowflake schema. And it's not right or wrong, but I believe in keep it simple. And by simplifying things and putting everything into the one products table, it just makes it a lot easier for the end user, if nothing else, let alone the simplicity that brings you as a DAX author. So this is why I prefer to use that layout. So just a couple of comments on relationship types. So all relationships in Power BI and Power Pivot, so I'm going to use the word Power Pivot, Power BI as a substitute for each other today, because Power Pivot is the underlying technology, and that's the way I learnt. So all relationships are one-to-many. Now, strictly this is not true, because in Power BI Desktop, as I've said down the bottom here, they've introduced a one-to-one relationship type. But if you think about it, a one-to-one relationship type is creating one of these satellite tables that you actually don't need. In my view, you don't need it. There may be a good business reason if you want to group all of your, let's say you want to group all of your customer geographic data into one table, and then you want to group all your customer socioeconomic data or something, or that's another type of data. It may make sense to put it into a separate table, and then you could create a one-to-one relationship. But generally speaking, I would recommend that you merge them into a single table. So I'm not going to talk about the one-to-one relationship. Also, I don't talk about it in this slide, but it is possible to have multiple relationships between the tables, but only one of them can be active at any one time. And there is a specific method during a calculation to tell Power Pivot to switch relationships from the current active one to the inactive one, and you can do that on demand. I'm not going to talk about that today either. Importantly, Power Pivot and Power BI Desktop are optimized for this relationship. It's optimized to take and use what I call a lookup table, the ones on the outside, which I'll explain in a second. It's optimized to put filters on those tables and then to propagate those filters into the center table. This one in the middle is only 60,000 rows, but it could be 2 billion rows, just like the keynote this morning. There's no reason why it couldn't be 2 billion rows. And so the engine is optimized to put filters on these external tables and then to propagate those filters onto the main table. And it's very fast, and that's why you get the performance that you do. There's no support for many-to-many relationships, so those of you that are SQL pros would know exactly what I'm talking about. Some Excel people also make the journey into Access in the past, particularly when you wanted to do some more complex things. I think that will happen less and less in the Power BI world, frankly. I think Access will be a diminishing product into the future. So you can't join tables with a many-to-many relationship. It's not possible. But there are DAX patterns, for the lack of a better description. There are DAX formulas that you can write, and there's a particular way that you can configure multiple one-to-many relationships, just like this, and make a many-to-many pattern work. The example, when I talk about many-to-many, I have an example where I use a racehorse syndicate. So you've got many people who own many different racehorses, and the racehorses are in many different races. So you've got lots of races with lots of racehorses, but lots of different people own those racehorses. So there's no one-to-one relationship between any of those things. And you can solve that using the many-to-many pattern. I'd recommend, I've actually got a blog article on that, and there's also some really good material on sequelbi.com. The Italians have got some great stuff. Now, here's the first thing that you absolutely must understand. You need to know the relationship, the direction of the relationship. This is absolutely fundamental to understanding everything about Power BI and Power Pivot. So filters propagate from the one side of the relationship to the many side of the relationship. That's the default behavior. And you need to understand that if you're going to understand evaluation context. Now, I recommend that you do yourself a favor and take this data model and lay it out like this. Now, I call this the Colley layout methodology because I learned it from Rob Colley. It's the way I learned to do it, and it's the way I teach. And the reason this is important is I'm not talking about the SQL guys right now. You know, you guys are pros, you work in this every day. But for Excel people, it just eliminates one level of complexity that you just don't need to deal with. If you lay it out this way, you can think about filters like water. Water flows downhill, it trickles downhill. But when it gets to the bottom, water doesn't come back up again, right? And so by laying it out this way, you get this visual clue and cue that the filters flow from the top tables down to the bottom tables, but they don't flow from the bottom tables back up to the top tables. Now, there is a thing called bidirectional filtering, which I'll talk about later, but this is the default behavior. So I recommend that you do this. And the other reason we call them lookup tables is in the old days, you'd go into your sales table and you'd write a VLOOKUP, and you'd go out to your other table and you'd bring back the product name and the product category name and so on. And so that concept of VLOOKUP and a lookup table is a good way to understand and remember those two terms. Okay, let me talk about evaluation context because that's the topic of the day. And I don't know about you, but frankly, I found this term pretty confusing the first time I read it, and couldn't be a more confusing label to such an important concept. But let me break it down for you because it's actually not that hard to understand once you understand each component. So let me start with the word context. And this is actually a term that you probably have used in language. You know what this means. And so if I was to say the phrase, I'm hot, what does that mean? Well, the answer is it depends. In this context, it could mean that, you know, I'm sweating, I'm hot for whatever reason, I've been for a run. I'm not sure that Seattle does a lot of this, just based on the tweets I saw coming in, but it could happen somewhere. I've just been to Texas, it was pretty hot down there. So in this context, it means a particular thing. But it could mean something different in a different context. So if I'm at the casino and I'm on a roll, then I could say I'm hot and someone would know exactly what I was talking about. I'm able to understand that in that context. And then thirdly, you have this, I don't know if this translates, I mean, I know Elvis came from the US, of course, but in Australia we have this Elvis festival every year, and like all the 50-somethings get dressed up in their Elvis kit and they get on a train and go out into the country and they all think they're pretty hot. But the point is that you can have exactly the same phrase in 3 different contexts and it means something completely different. So that's what I mean when I talk about the word context. I mean, it depends on the situation. So if we now translate that over to the term evaluation context, what it means is that every formula can give a different result in a different context. That's all it means. And in fact, if I take it one step further, evaluation contexts, plural, the reason it's got an S is there are 2 types of context. And I actually had an argument with my publisher because I thought it should be evaluation context, meaning plural, but she set me straight. That wasn't correct. So every formula can have a different result depending on the context. So the first type of context is called filter context. And filter context is provided by the coordinates of the visual. So by coordinates, what I mean is it comes from the columns of the visual. So this is a matrix. It comes from the columns. It comes from the rows. In fact, it can be nested rows. I've got 2 different columns of data here in this matrix going in nested rows. It also comes from slices. And as you would know in Power BI Desktop, it can come from almost anywhere on the canvas itself. It can come from another visual. And being able to read and understand filter context is absolutely fundamental in being able to understand evaluation contexts and also to be able to debug your formulas. Now, in addition, most of you would know, since you're sort of immediate, is that the calculate function can be used to modify the natural filtering behavior coming from your visual. It's the only function that can modify the filter context, and that's why it's such an important function. And as I mentioned on the previous slide, filters automatically flow from the one side of the relationship to the many side of the relationship. They don't flow the other way automatically. It is possible to filter a table on the one side, but it's not using automatic filter propagation. So that's filter context. Close the book. New topic. Row context, completely different. These two things have nothing to do with each other, a brand new topic. So row context exists inside a calculated column. And when I teach context transition, I always teach it inside a calculated column. And that's because it's the most intuitive place to see it in action. And most Excel people, who are my customers typically, understand the concept of looking at a grid and putting a formula and seeing the numbers come down the page. However, row context also exists in some of the special functions like filter and SumX, and there's many more. I mean, there's a large number. We'll talk about that as we get into the presentation. Couple of important points. So row context does not follow a relationship, and a row context does not create a filter context. Two completely separate topics. And I'm going to show you that even though a row context does not create a filter context, it is possible to manually override that behavior by using the calculate function and convert a row context into a filter context. But we'll do that live in a demo. That's the best way to cover this off. Okay, so let me see if I can get organized here. I'll switch over. I'm going to come back to some slides as we need to. And so here I have my AdventureWorks star schema model, and it's laid out like this. So as I mentioned up front, I'd recommend, if you're an Excel pro, the first thing I would recommend you do once you load your data up and have your relationships joined is lay it out like this. Once you do that, you can click on the Fit to Screen button, and now it's one less thing I have to worry about. If there's a filter on the top table, it's going to filter the bottom one. The bottom one doesn't filter the top one, and so that's usually a good approach. Okay, so let me jump into the sales table now, and it's going to be a bit of a make a guess sort of thing. So I'm going to put some stuff up. I'm not going to ask people to shout out or put up their hands or anything like that, but take a position would be my advice. So I'm going to ask you some questions. What's the answer going to be? Take a position in your mind, and that way you'll sort of get engaged and involved in the process. So first of all, I'm going to go to the sales table. And in my sales table, I've got a sales amount column and I've got a tax amount column. Now, if you're an Excel person, the first thing you're going to say is, fabulous. I've got sales, I've got tax, but I don't have sales plus tax, so I'm going to go and create a new calculated column. And I'm about to do that too. However, my advice to you is don't do that. So what I'm going to show you now is for L&D purposes only, and it's actually not good practice to do this. And we can have a chat about that later, actually, if there's time. I've got a blog article specifically talking about calculated columns versus measures. My general advice to the Excel folk, I learned not to tell the SQL folk how to suck eggs because they actually know what they're doing most of the time. So. But for the Excel people that are learning, my general advice is, if you know why it should be a calculated column, go ahead and do it. But if you don't know why, then assume that it's the wrong approach until you know why. And that will keep you out of trouble. Okay, so here's my sales amount, here's my tax amount. I'm going to create a brand new column called Sales Including Tax. Now, up here on the Modeling tab, there are 3 buttons: New Measure, New Column, New Table. I never use those buttons because they cause me grief. What happens if you create a new measure and you've accidentally got the wrong table over here selected? You're going to put the measure in the wrong table. And then you go to look in the table and you can't find it. You say, well, maybe I didn't do it. So you do it again. And now it says, oh, error, you've already got a measure called that name. I mean, this must have happened to half of you. So this is the way I do it. I come to the sales table, decide where I'm going to put it, right-click, new column. That way there's no misunderstanding. It's going to go into the sales table. So sales, including tax, column. I'm going to call them columns and measures because I'm going to do both. And it's pretty simple. The IntelliSense is fabulous in Power BI Desktop, not so good in Excel. So I want to add the sales amount, so I don't even have to name the table. I can just go straight to the column name, push the tab, plus tax amount, and I'm about to hit enter, and the question for you is, what number am I going to get down the side? Oh, there it is. I didn't have much time to check. Okay, so what we've got going down the column here is we've got a different answer for every single row. But how can that be? I didn't write the 60,398 rows. I didn't write 60,000 formulas. I only wrote one formula. So how is it that I'm getting a different number all the way down the page? And if you're an Excel person or even a SQL Pro, nothing there would surprise you. You're probably even scratching your head and why am I going on about this? Because it's obvious that that's what you're going to get. And so the reason this works is that we've written a single measure and a single calculated column, and this column says take the sales amount and add it to the tax amount. But a calculated column has a very specific skill. It knows how to evaluate this formula one row at a time. Because you think about it, this column has got 60,000 different values, and this column has got 60,000 different values too. How does it know which ones to add together? And in its simplest form, the way it knows is because it works one row at a time, and for the first row, it says, for this row, what is sales amount plus tax? It adds them together and puts the answer. And then it goes to the next row and says, what about this for this row? What's sales amount plus tax amount? And we talk about this iterating through the table in a row context. That's the technical term. The non-technical term is this formula is evaluated row by row and the answer is placed inside the table. Okay, so that's our first DAX calculated column. I've just taken a copy, Control-C. I'm going to the products table and I'm going to create a new column. And I'm going to paste exactly the same column in the products table. And now it doesn't work. So what's happening here is that this column says a single value for sales amount, table sales cannot be determined. But what's actually happening is that this column is in the sales table and we're writing the column inside the products table. And remember I said that relationships, the row context does not follow a relationship. So there's no way that you can refer to a column. I call this a naked column. So it's a column that's got nothing wrapped around it. There's no aggregation function. So you can't refer to naked columns inside a column inside another table. So that's not allowed. But so let me just delete that actually just to keep things tidy. Okay, so let me do one more thing. I'm going to right click on the sales table. This time I'm going to create a measure. So a measure is different to a column, of course. But I'm going to paste the exact same formula. This is my measure. And as you can probably see from the IntelliSense, I get the same error. But this is the concept of evaluation context. Every formula can have a different result depending on the context. When I put this formula in a column in the sales table, it works. When I put exactly the same formula inside a measure, I get an error. And the reason I get an error is that this, what I would call a regular measure, I'm just referring to naked columns here, and it doesn't know how to handle it. And the reason is that this regular measure has no concept of row by row evaluation. It doesn't know how to do it. You can help it, and we'll look at a measure in a minute that does do it, but this straight out measure like this, it's not possible to refer to a naked column because it has no concept of row by row evaluation. And so coming from an Excel world, you might want to wrap a sum function. And if I start to type in the sum function here, IntelliSense is pretty good. It kicks in and says, sum, you tell me the column name and I'll add up all the numbers in that column. That's what the sum function does. And if I try and wrap those two columns in a sum function, I still get an error message because I'm trying to do this plus that inside a sum function. That's not allowed. The only thing I can do to make this measure work, or actually it's not the only thing, but the thing I am going to do, is to wrap both of those columns inside a sum. So sum acts on an entire column. I'm going to add the first column, I'm going to sum it up, I'm going to do the same to the second column, and now it works. Okay, so let me go into my visual now, and let's bring those couple of measures in. One measure, one calculated column. So here's my total sales including tax calc column, and here's my total sales including tax measure. And maybe not surprisingly, I get exactly the same answer. And so what's the difference, I hear you asking? And why are you telling me not to use columns when measures give me exactly the same answer? Well, the reason is that inside this sales table, this calculated column that we did here, every single answer has been evaluated row by row, and it's stored in the column, and it's taking up memory, and it's stored on disk. And when you add many columns, so we've just added one for sales including tax, but what about sales, what about margin? What about margin percent? And I need this and I need that. I need cost excluding delivery, and I need one including delivery. And all of these columns, it's not linear, so the more columns you get, it starts to shoot off the chart exponentially as far as taking up space, and that's why we don't need it. And frankly, if you end up with the same answer and you don't have to store all these interim values in your data model, why would you? So that's the reason that we don't do that. Okay, so let's just have a brief review of where we're at. We've got our calculated column here. It's just adding up two naked columns. The reason it can do that is because it's a calculated column, it's got a row context, and when it has a row context, it's quite capable of evaluating one row at a time. And in the case of the measure, which I have here, a measure doesn't have a row context. We're not allowed to refer to naked measures, to naked columns, and so I've wrapped them inside a sum, and the sum is adding them together. So there is one more way of doing this, and that's to write a measure, and this time I'm going to write a new measure using SumX. So I'm going to call, this time I'll do sales including tax SumX version. And SumX, as many of you would know, SumX is a particular measure that does have a row context. The sum function doesn't. You just give me the column and I'll add it up. Don't ask me to do anything row by row. SumX is different. The SumX function, if you look at the IntelliSense there, it's asking for the name of the table and the expression, and it returns the sum of the expression evaluated for each row in a table. And the easy way to know whether the measure, or the function more correctly, the easiest way to know whether the function has a row context or not is that it always asks for the name of the table. If the function asks for the name of the table, then it probably has a row context. I'm not actually sure 100% whether that's true or not, but I believe that to be true. So SumX wants to know the name of the table. It's the sales table. And now it's quite permissible to add up these sales amounts plus the tax. So that same formula, this piece of the formula stub, failed before, wasn't allowed, but when I do that now inside of SumX, I get exactly the same result. Once again, not surprising, but the point is that this particular formula, when you have a row context, you are allowed to refer to naked columns. When you don't have a row context, you're not allowed to refer to naked columns. Okay, any questions? I'll just keep moving, shout out if you need to. Okay, so let's just a brief summary of what we've talked about so far. So a row context exists inside a calculated column. I'm not advising that you go away and write lots of calculated columns. The reason I write them is because you can see what's going on row by row. We've also learned that a row context exists in an iterating function. We looked at the SumX version, and once you've got that, you can refer to naked columns. It also exists in filter. In fact, there's many other more complex ones which I'm not going to cover today. But a row context does not exist in a regular measure, and so if I try and, I've actually got a little rogue bracket there, which is not supposed to be there, but if I try to refer to naked columns within a regular measure, it's going to throw an error telling you that you can't write that formula because it doesn't have a row context. So regular measures only work on columns because there's no concept of a row by row evaluation. Okay, so time to move on to filter context. Yes? Okay, so the question, just for the audio, for the video, so the question is, what's better, sum versus sum x, and sum x is slower. Actually, the opposite is true, and it's not intuitive, and I can tell you that what I've learnt over 3 years of doing this stuff myself is that you think you know something, and then one day you find out you didn't know it, and normally that's by some blog article that Marco Russo writes at some point in time. And the other thing is that, you know, it's just hard to take everything in when you don't understand everything, and so I can hear the same thing like in year one, I hear it again now. Now I understand it. When I heard it 2 years ago, it didn't really make any sense to me. So it's actually more efficient. Well, if I can quote Marco, it depends. However, it's generally more efficient, I believe, to do sum x, and that's because compression is all about the number of unique values in a column. And if you think about, say, a quantity and price column, which you would use in a sum x, the number of unique values in those two columns is relatively low, compared with the extended version, which is quantity times price, giving you the extended amount. So by definition, the extended amount column is going to have more unique values, almost guaranteed, than the quantity column and the price column. And so for that reason, quantity and price may compress better than extended amount, and because of the optimization in the engine and the way that it operates. So we think about this row-wise calculation, but in reality it's optimized under the hood to give you really fast and performant results. So I certainly didn't know that in the first 18 months of what I was doing, and but that's what I believe to be true today. Another question? Yes, sir. Well, if you're doing views in SQL and you're building the columns in SQL, then sure, that's fine. The main thing is not to bring in redundant data. So if you're going to bring in quantity and unit price, don't bring in extended amount. Like, make a decision. You've got 3 columns, you can derive 2 from the other one, so make a decision which one you're going to bring in and don't bring in the extra ones. And so that's, I think, if I understood your question correctly, yeah, so if it's coming in from SQL. The general rules I suggest for calculated columns or any columns coming in from your data source are if you need to slice on it, so you need to put it on a slicer or rows or columns in your visual, it must be a column. You can't put a measure confusing terms, you can't put a measure onto a column in a visual. You can't put a measure onto a row in a visual, but you can put a column. So if you need that, then you definitely would do that. The other thing is that, generally speaking, for a calculated column, if the number of unique values is low, then generally speaking, it doesn't matter. You know, the less unique values in a column, the less you should worry about it. So, and also, if you're writing calculated columns on lookup tables, because those tables are generally smaller, then they have a lower impact as well. So, but this is a huge topic in its own right. So, yes, another question. So the question was, instead of calculated columns, should we do it in M? Well, I think early on, calculated columns were less efficient than the equivalent imported from scratch. I'm not convinced that that's the case today, although I don't know that for sure. I mean, if you need the column, I certainly believe push it upstream as far as you can. So best case, get your IT team to write a view and add the column in SQL. That's the best option. Second best, put it into the M code as you load the data. Third best is write the calculated column. So, but in actual fact, there's probably even something better than the first best, and that is if you don't need it, don't bring it in. So only bring in what you need. Okay, so let's keep going. So we're going to talk about filter context. And so just let me see where I'm at. So I'm going to write a new measure on the sales table. And so same approach as before. I recommend don't come up here, don't click these buttons. I've already got the products table clicked and it'll go in the wrong place. So right click on the sales table, new measure, and I'm just going to create a simple total sales measure. I'm going to try. Oh. User error. Total sales. And it's just a simple sum of the sales. I'm used to typing the table name first, sales amount. Okay, so if I write this measure, I always recommend straight away, before you do anything else, go and apply formatting. If you do it now, you won't have to go hunting for it later. So total sales, and I'm going to add this into my visual. And here we go. I wrote a single formula. Let me bring it up on the screen. There it is. And so here's my total sales. And despite writing a single formula, I've got, well, I can see 5 different numbers on the screen there. And if I zoom out, I've actually got 6 different answers. How is this possible? How can I write a single formula and get 6 different answers? Now, once again, I don't expect anyone to look at that and say, well, that doesn't look right. I expect everyone to look at that and go, yeah, of course, that's how it works. But you're doing that based on probably your knowledge of how a pivot table works and your expectations of how a pivot table works. But the real thing is you need to understand why it works. You need to understand how the engine works. And so the way the engine works is it uses filters. And the way I would encourage you to think about these things is to look at an individual cell, and I've highlighted this cell here, and say, what is filtering this cell in this particular table? And in this case, I've got a column here coming from the customer occupation, coming from the customer table, the column's called occupation, and I've got a filter effectively on customer occupation is equal to clerical. Now we call this the initial filter context. And this is a really important skill to look and be able to read where your initial filter context is coming from, because it's fundamental to understanding the broader topic of evaluation context. Now I can add some additional filters here, so I could put that's not what I meant to do. I forgot that I expanded that canvas. So I'm going to put a filter on year here, and I could apply a filter. And so let me ask you now, so don't have to answer out loud, but just think about it. What is filtering this cell that I've got highlighted on the screen now? Because we need to understand what the initial filter context is if we want to understand how this formula is being evaluated. Now in this case, I've got a slicer out here on the right, which has got a filter on calendar year is 2003. I've also got customer occupation on rows as well. It's still there. But the customer occupation is not filtering this cell. This cell is completely unfiltered by these rows. And so this is another important concept that you understand. And this number is not the addition of these 5 numbers. That's not how it works. The way it works is it starts off with the question, what is filtering this cell? And the answer is calendar year is 2003. That's it. Nothing else is filtering that cell. And then you need to learn to be able to think about filter propagation, because once the filter is on this table here, calendar year is 2003, that filter will automatically flow down through this relationship in the direction of the arrow from the one side to the many side. And now the sales table is filtered so it only contains sales for the year 2003. And so if you can learn to imagine those tables like that, that's a great skill to have. Just sort of think mentally. I can see in my mind that this table has now been filtered. It only contains sales for 2003. Okay, so I've talked about reading filter context. Okay, so let me do something different now, because this is where it starts to get pretty funky. Let me find my total sales measure. Remember the measure I just wrote? I'm just going to copy it here. I'm going to copy that measure, and I'm going to go to my sales table, and I'm going to go to my customers table. I'm going to create a brand new measure. Sorry, I'm not going to create a brand new measure. I'm going to create a brand new column, and I'm going to paste the exact same formula which I just wrote for my measure. I'm going to call this total sales column so I don't get confused. So here's my question for you is, what value do you expect to see row by row appearing down the page in this data view? So you can have a crack at what you expect to see, and I'm just going to click tick and click on the column, and this is what we get. We end up getting 29 million, which is the total for the entire database all the way down the page. And this is completely not intuitive. You know, this is not what most people would expect. I can't get my Zoom to work, so and understanding what's happening here is fundamental to understanding evaluation context. So just if I can refer you back to my slides, I said up front there's a filter context and there's a row context. A row context does not create a filter context. They're two completely different things. So I've got a filter context here. So I go to the first row in the customers table. Sorry, I've got a row context. I go to the first row in the customers table and I say, well, for this row, I know which row I'm in, but then I ask the question, what's the sum of the sales amount column? Well, I've got a row context. If I don't have a filter context, then the sales table is not filtered. There's no visual, like there's nothing filtering from the canvas. There's no visual, there's no filter context. This column, by definition, is completely unfiltered. It has to return 29 million. There's nothing else that makes sense. So a row context and a visual and a filter context are two completely different things. Okay, I'm going to delete this. Once again, these are only for demonstration purposes. So let me go back to the slides just to do a recap on where we're at. I might have to pick up the pace a little bit. I always underestimate how long these things take. So just a brief summary on filter context. So a filter context exists always within a visual in Power BI. It exists in a pivot table in Excel. And Calculate can modify the filter context. We haven't looked at that yet. We're going to look at that in a second. A filter context propagates from the one side of the relationship to the many side of the relationship, and we can think of that as flowing downhill. And there is this other thing called bidirectional filters, which we'll talk about later. So, time to talk about Calculate and context transition, and this will sort of close out the things that I've talked about so far. So here is the syntax for Calculate. Let me bring it up. So Calculate takes a measure expression, which could be a measure or some other formula, and then it can optionally have one or more filters that it's going to apply, and those filters can come in two different flavors. There can be a simple filter like product category is clothing, or a more advanced filter where there's a table, and I think I'm going to skip the advanced filters just to save a little bit of time. Okay, I talked about this in my previous session, so those of you that came to that, you would have already seen this. Who knows what this thing is? Like you're showing your age if you put your hand up. So this is an old mechanical adding machine, and this is in the pre-solid state, pre-electronic calculator world. And the way it works is you've got these sort of button registers here. So this one on the right-hand side is the cents, and then the next one's the 10-cent register, and then it's the dollars, $10, $100, $1,000, and so on. And the way it used to work is that you would come to this thing, and you'd sort of, if you want to punch in $1,023.56, you'd find that number in the right column, and you punch it in. But the point is, when you punch that number in, nothing happens. The button gets stuck down. It says, okay, you've pushed this button, but nothing happens until you pull this handle. And when you pull the handle, the machine cranks over and takes all of those inputs that you put in, and it effectively runs the engine and gives you the result. In this case, it's adding up. And so I like to think of Calculate as being that handle, because all Calculate is an instruction to Power Pivot and Power BI Desktop time to go and run the filter machine. So you're applying different filters inside of Calculate, and when that Calculate function gets executed, you say, time to go and run the filter propagation machine. And when it runs the machine, the filters propagate downhill, as we've talked about before. So I just find that a useful way to think about Calculate. Okay, let me do a demo and see where I'm at. So I'm going to quickly write a new measure using Calculate. So I'm going to go to the sales table, and I'm going to write a brand new measure, right-click, new measure, total sales from bikes, and equals Calculate, total sales. So this time I'm going to reuse the measure that I've got, and I'm going to add a new filter myself on products category equals bikes. And so I guess most of you have sort of got to this point at some point in time. Click the tick box before you do anything else. Try and come in here, apply the formatting. If you do it now, save yourself pain down the track. And then somewhere down here is my total sales from bikes. And so now we've got a slightly different behavior where if I was to take this particular cell here, I've got initial filter context coming from calendar year as 2003. I've also got initial filter context coming from customer occupation is a skilled manual worker. However, in addition, because there's a Calculate involved, there's a new filter that's being applied by the Calculate, and this is what really makes Power Pivot such a great tool, is that you can pretty much do whatever you want. I'm going to just skip over. I was going to do another example, but I think I will move on just to save some time so that we can get on to context transition. So the use of calculate that I've talked about here, we've actually applied a filter, in this case product category is equal to bikes. But it is possible to write a calculate function that doesn't have any filter inputs. And so let me come back to the customers table, and you should be getting this down pat now. So if I write a test measure that says sum of sales extended sales amount. So you should know what number you're going to get down the page. You'll end up with the same number all the way down the page. There's a row context, but there's no filter context. And so here's the other use case for calculate. If I wrap this formula in my calculated column inside a calculate, just like that, then something magical happens. What happens is there is always a row context. That was there from the start. But what calculate does is it converts the row context into a filter context. And now we have a row context and a filter context. Although I was watching something by Alberto Ferrari the other day, and he told me that the row context disappears and we're just left with a filter context. I need to check with him about that. Not really sure. But anyway, we certainly, we're doing row by row evaluation, and we now have a filter context. So I just want to quickly show you line by line how that operates so that you get your head around it. So first of all, when I wrote the first measure, sum of sales extended amount, just like this one here, what happened, the formula went to the first row in the customers table. Remember, it's got a row context. It knows how to do row by row evaluation. And then it says, what is the sum of sales extended amount in the current context? Well, there's no filtering, so it's the entire unfiltered column. The answer is 29 million. It takes that number, puts it in the cell, and then it goes to the second cell in a row context. And it asks the same question. For this row, given that I'm talking about this customer, what is the current value of sum sales extended amount? Well, nothing's changed. There's still no filtering, and therefore we're always going to get 29.3 million no matter what happens down through as we iterate down through this customers table. So that's why, in this case, that formula didn't give us what we were expecting, which was total sales for the customer. Let me show you how context transition does work. In this case, we've wrapped calculate around our measure. Now what happens is that we go to the first row in the customers table, and because of this calculate here, calculate converts the row context into a filter context. We now have a filter context on the sales table, and this sales table now gets filtered so that just the rows for this one customer are visible. And if you can imagine that table, it adds up the value, this piece last, takes the number, puts it back into the cell, and then it goes to the second customer in the row context. And because of the calculate, the same thing happens again and again. And so this way, it's iterating over the table, and literally in the background, these filters are being applied one row at a time as the row context is converted into a filter context. So let me skip through those. So hopefully that makes sense. You know, to see it happening like that can be useful. All right, we're almost out of time, so I just want to show you two more things. Better change devices here. Oops, user error again. Okay, so two more things. I want to show you that SumX can also have context transition. So I'm just quickly going to remove my total sales from bikes, and I'm going to create a new measure here, total sales SumX version. So we saw this before. It's SumX over the sales table. Sorry, I'm going to do it over the customers table. And if I do the same thing here, sum of sales amount, and I won't do the formatting just to save a little bit of time, and I put that in here. Now we get some crazy number, but now that you've seen me do this inside a calculated column, you know what's happening. What's happening here is that SumX is iterating, in this case, over the customers table. It's going one row at a time. It's got a row context but no filter context. And it's saying, in the current row context, what is the value of this? And we know it's 29 million because there's no filter context. And so for every customer in the table, it's adding 29 million, and we end up with this massive number down the bottom. And it's easy to force context transition. That's the technical term. All we have to do is wrap this inside a calculate. And when you do that, the measure will give you the same number as before. It's just formatted slightly different. And so for every iteration of the customers table, context transition is occurring. The last thing that's a little bit hard to get your head around, and it's worth pointing out before I wrap up, this was the original formula that didn't work, where I had sum of sales extended amount, sales amount. If I go to the total sales measure is exactly the same formula, sum of sales amount. And so it's a reasonable thing to expect that if I replace this with the measure, I should get the same answer. And unfortunately, that's not what happens. When you put a measure inside an iterator, inside something with a row context, a measure has what we called an implicit calculate. You can't see it. Every time you write the measure and you hit save, the machine wraps a calculator around there without you seeing it. And so believe me, it's there. And so whenever you put a measure inside a row context, by definition, it's going to force context transition. Okay, so I'm out of time, so I'm going to skip the bidirectional filtering. You're probably familiar with that anyway. Bidirectional filtering is a feature you can go in and switch and force the filters to go in the other direction. So just a summary on calculate and context transition. So calculate can modify the initial filter context. It can add, modify, and remove filters. A row context does not create a filter context, and we saw that inside our calculated column here. And we also learnt that I could trigger context transition by wrapping a calculate around this particular formula here. We made it. And every measure has an implicit calculate that you can't see, and so measures always trigger context transition. So. Okay, I'm going to finish up there, skip over bidirectional filtering. Thank you very much. I hope this has been useful. I'm happy to I've probably got a couple of minutes. Actually, I'm 2 minutes over, so I don't have minutes, but if you want to come and see me, please do. Thank you very much.